I'm sorry. Let's see if I can stop. Okay, so today we're going to be talking about Smart Engineering Center. I'm pretty excited about this new software that we produced. This started from a work with a company in Spain. Company is Iberdrola. Iberdrola is the owner of Avangrid here in the US, and Iberdrola Renewables, or Avangrid Renewables. So we started this project over there. It's called Smart Engineering Center. It's basically taking care of one specific process in the engineering department. The process is every new connection, so a project design, right? We have the overview of the project design process. A customer asks for a connection, a new connection, or moving a connection from one place to another. And there's an entire process within the company that takes place to basically, oh gosh, isn't this terrible? I hate animation. Someone put the animation in this. So basically the customer asks, and then there is an entire process within the company to make that request to become into a project, in particular within the validation of minimum required data, determination of geometric layout, so where the line has to pass. This is an extension of the network. Analysis of the construction electrical data to do the existing work, reaching a basically bill of materials, or budgeting, validation of the minimum required budgeting, and finally the characterization of the network that has to be done before the work can be done. What does Smart Engineering Center? Very shortly, Smart Engineering Center is trying to automate as much as possible this process, right? From when the form is received, from when the request of the customer is received, to when the bill of material, the executive project, with the cartography, with the lines, exactly the places where the new line has to pass by, we try to automate it as much as possible. The numbers are astonishing, what they've achieved. We will see them later. So, inputs the Smart Engineering Center receives is service provision, right? From here, regulatory information. This is all the regulation that basically are typical of the state, the county, oh gosh, the state of the county, etc. The construction models that are in the company, right? The network characterization, so a specific area where that part of the network is to be extended. The state register and cartography, that is property of the county, for example. And then information from the GIS, information from the commercial system, because we get information from the customer information. And the output is a blueprint, is the final solution, and is the budget. So what we're trying to do is cost reduction, shorter deadlines, agility in obtaining result, flexibility, adaptability, and quality of service. Good words to basically say, okay, what's the level of automation that we reach here? I'm sorry I have to deal with this. Okay, let's see if it stops. All right, so traditional operation will be 20% will be administrative tasks. 20% will be administrative tasks. 30% will be engineer activities, and then you have this research, discovery requirements, site visit, etc. The objective that was reached, 80% of the automation, so 80% automation. There still is a 20% administrative task, the rest is automated. Year one, we expect a 60% automation of the process. The process does use artificial intelligence, does use machine learning, so we actually have to train the models. Year two, we reach a 70% automation. Year three, we reach a 90% automation. The system gives an output of all the processes that have been automated, so all the designs that have been automated. Suppose you have 1,000 requests. It will give you, if it automates 60%, you will have 600 automated results with the blueprint and executive. And all that has not been automated, you will have a list of why it has not been automated. And that's where there's a manual intervention to readapt, to put a new rule. That's why the system learns, right? An example of what is happening today in the US, I just took two customers, nothing personal. This is on the webpage. So, and so in the case of Georgia Power, we are basically looking at this phase here. Within within a typical process. We are basically trying to automate this. So Georgia Power declared us around 30 days of work to get a design project. In the case of MB Energy, the initiation is basically 2 to 4 weeks. The design is basically between 6 and 8 weeks. Again, we are trying to automate this part here. We are trying to reduce, depending on the information that is available, we're trying to reduce the need for a physical inspection on site, right? And of course, with not construction and meter set is something that you have to physically be there. So this is the objective of Smart Engineering Center. Smart Engineering Center functions on 3 different intelligence engines. The engines are the electrical solution automation, the blueprint engine, and the budgeting engine. We have, from a client request, basically the information goes through this, and through this, and finally, the information is passed on to the asset management systems, for example, the GIS, because there is an extension in the network. So we pass a file that is then is the input for the GIS, right, and creates the file. To understand in your own organization what is the return of investment of this, there's a very simple calculation that you can do. I didn't put any number, right? And you say, how many total annual requests do I get for an extension of the network? Let's say that we automate, how many of them require a site visit, a field visit? Let's say 60% of them. What's the average preparation time? 3 hours, maybe 5, put your number, 5, 6, 7. Average field visit time, 3 hours. Project engineering staff cost, a price per hour. Suppose 60% automation, and you calculate the saving here. So calculate 60% of that cost, and that will give you immediately the number of money that you can save, right? CapEx cost is going to be the cost to buy the software, and the payback, we found that the payback was less than a year. A bit more detail about this. So this is a more graphical understanding of what the process I was showing you before. You get a connection request from the customer, right, with a number of information. This is the input for the system, right? There's electrical solution, technical and financial solution, find out, information to planning of the network, interchange of information with the GIS, and then the number of documents that are prepared already automatically, easement, permits, and payments, all the payments required for right-of-way, for example, right? And the construction design, and then, of course, there is this part here is the physical part to build the project. More graphical terms. What do we mean by automation design? This is the creation of the cable route. So where the cable, the conductor, if it's an overhead, if it's an underground cable, what it has to pass. We take the existing line, the existing cartography, right, and we just design the new piece of cable where the cable is to pass. So you get a customer request, and the output is basically something like this with all the associated files to basically start the entire process of construction or permits, for example, even information that the customer has to receive to go and talk to his neighbors for the easement, for example, if that is required by the particular extension of the network. This was one of the for example. See, it's in Spanish. Sorry about the anybody. Basically, they had to design this new piece of line here, right? And the request was to connect this house here, and the design came out directly from there. Of course, this is a very simple case. I wanted to say what had been done in when they say the improved algorithm. So this entire project started, and this was the proof of value, started by showing, let me see if I have it here. Sorry. So this entire project started by demonstrating. So this started from actually an image before this. The same area, this is an industrial area, the same area was basically, they mapped all the points where they had customer connection, no network, right? Just the industrial area and all the different points where the customer connection were. And then they run the algorithm by using the cartography, so actually the places where the buildings were, the streets, right? And they said, okay, how can we connect all these points with the network? So the algorithm started to work and came out with a network design, and then they overlapped with existing cartography, and they found actually there was an improvement in the terms of material used and time. So that was the first proof of value, and then basically started the project. Today the project is working, the system is working, is in use. Although at the moment they're getting the inputs out from the system, and Iberdrola is looking at comparing with what the designer would do. And each time it overlaps, then they say, okay, this becomes an executive project. So it's in a phase where they're actually still testing, but they're already using it. They're already using the design directly. So it's a verification that the design is actually well done, and then the design becomes operative. A few references. Here's the Union Fenosa distribution in Spain, and you have the number of current total automation about 63%. Sorry about this. 63% of automation of design. These are what we're saying, work supply, tertiary use, single family house, industrial use, agriculture, and buildings. All the connection requests that they are already processing, right? This is Viesgo, another utility in Spain, 84% of automation of the processes, and these are the test cases that analyzed. We have Iberdrola here, 78% of current automation, and this is Negia, which again is the Naturgy group, and then the other one is Enel, where we're doing this project is just started, and it's going to be done in Italy, Spain, Peru, Colombia, Chile, and Brazil. So this is just started. Okay, so I stop here because we reached the end of the hour, and if you have any questions, please ask them. So I had to run a bit because with less time. So.